Hi, I'm Kat. I'm a student at Barnard College, and I'm going to be presenting my work on program synthesis and live coding. This is a joint work with members of my lab and with my advisor, Mark Santalucito. I'm going to start with some definitions before I introduce our tool. So today we're going to be generating computer music using program synthesis and live coding. Our interface contains a step sequencer. A step sequencer is a digital interface inspired by classic hardware step sequencers that have rows or configurable switches or knobs used to generate repeating musical patterns. In our context, we have a step sequencer of drum beats, which can be programmed in using live code to generate a repeating beat pattern. Our application uses program synthesis to connect a live coding element and a drum sequencer together and establish a relationship between the two. Program synthesis is the task of automatically finding a program in the underlying programming language that satisfies the user intent expressed in the form of some specification. In our case, the specification will be clicks on the interface, and the task will be finding code that maps to those exact clicks, and that code will be generated in the live coding element. And also, program synthesis is really unique because it allows users to sort of be exposed to code that they haven't wrote themselves, and it can be an educational tool to engage people that are not programmers, but expose them to a high level of coding fluency. Our tool uses an array-based structure to store the data from the user input. So we support both volume data and duration data. Here I have an example of track 1, which is clicked at index 0, 2, and 4. And we can see that here with this array with 1, 0, 1, 0, 1. So the array keeps track of the volume data and the duration data. And the volume data is represented by small inner circles or clicks. The duration data is represented by partitions within the circle that are controlled using shift-click. So now I'm going to do a demo of the tool itself.
I just wanted to check in. Can you guys see the whole screen?
Yeah, I think I'm seeing your whole screen.
Okay, great. Okay, cool. I'm just looking at it too. Just wanted to make sure. Okay, I'm gonna continue with the demo.
Cool.
So this is the live coding web drum machine. And we have our live coding element on the left and our sequencer on the right, which takes in 6 different drum patterns. I'm going to select the vocal kit, and I'm going to start clicking and show you guys how this works. So here we go. We have a pattern that is mapped here, and this represents the beat pattern that I've clicked. We can also use our DSL to generate drum beats. Watch as track 3 takes on this set all instruction. We also have a backbeat function that can be used to generate a backbeat on track 6. So you can see here, I've adjusted the slider to rise as the sequencer steps through the indices. So that's how you hear this pitch that is sort of rising every time it approaches the end of the measure. And finally, we can mess around with the duration data to get a really interesting representation on the GUI. If I just copy this pattern function on track 6, so you can see that that will generate a really interesting graphical display on track 6. Cool. So that is the live coding aspect of the tool. We also have a record button so that you can record beats that you've made and download them to your local machine. And finally, we have 3 different views, which we will explore in a user study. So our goal is to engage as many people as possible with our tool using program synthesis and live coding. We're going to test these views and see which one generates the greatest amount of clicks in the interface so that we can optimize our interface for users and really engage people with minimal coding experience and have them use our tool and understand what's going on. Thank you, and I'm going to open up the floor. Thank you for listening.
All right,